Welcome back. Here today we're talking about apply the remainder and factor theorem, which means nothing to most people. But what we're really talking about is polynomial long division. Now I know the terminology long division brings back many fond memories of middle school. And so I probably should start there with long division from middle school. Things like 24 divided into 1, 2, 3, 4, 5, 6. Okay? So remember that's a 2, not a 1 there. 24 goes into this. So how many times does 24 go into 123, and so on and so forth? It doesn't go into 12, so I skip over to this place right here, and I ask myself, how many times does it go into 123? Well, it could go into 123. 24 times 4 is 96. 24 times 5 is 116. So I put a 5 here, and I put a 116 right here. Hopefully you guys remember something like that. I subtract these things, 123 minus 116. I have a 7, bring down my 4. 24 goes into 74 3 times. And 24 is, it's going to be 72. And I have a 2 remaining. Drop down the 5. It's going to go in there 1 time. So 25 minus 24. Subtract, I get a 16. Well, 16 doesn't go into 24, or 24 doesn't go into 16. So I have 531, and remember this, remember R, 16. And some of you are saying, oh, wait a minute, remember you could come up with that decimal? Well, you could, but we really like the remainder for what we're going to do today. So we're going to leave that at R, 16. So that is regular number long division. Today, we're going to do polynomial long divisions, which simply means with letters. If you hated it the first time, you better learn to like it this time. Synthetic division is a different way of doing things. Some of you might think it's easier. It's just another way, and I'll show you that in a minute. So another way. How about that? For those of you who think I have terrible handwriting, that is a new all-time high. Let's take a look at example 1 here. And maybe we need to change the color to keep, soothe out the mood a little bit. How about this cool blue color? Let's see how that looks for a little while. Division. I'm going to do long division here. Just like with my numbers, what I'm trying to do is divide this whole thing into this whole thing. Now, the question was, divide x squared plus 2x plus 4 into 4x to the 4th plus 5x squared minus 9x plus 18. I hope you notice that there's not an x to the 3rd term here. So we made that 0 x to the 3rd because it's important to have places on all of these. Okay? Now, x squared times what? Now, what you're trying to get rid of is this first number only. So x squared times what is going to be 4x squared, 4x to the 4th. Well, hopefully you see that that is 4x squared. And I'm going to put that in the x squared place right here, 4x squared. And so if I multiply all 3 of these things by 4x squared, the first one better be 4x to the 4th. Okay? 4x to the 4th plus 8x cubed plus 16x squared. I'm going to change that color again because I don't like that color. Let's try this army green, make us feel tough. So what we do, just like we did with the addition and the simple number one, we subtract 4x to the 4th minus 4x to the 4th, 0. Should be 0 every time. Must be 0. 0 minus 8 is negative 8x to the 3rd. And 5 minus 16 is negative 11 x squared. And then just like in the normal one, I brought down my negative 9x. I don't have to bring down the 18 yet. I'm waiting on that. Okay, next question. What times x squared equals negative 8x cubed? Negative 8x. So I multiply everything here by negative 8x, and I get negative 8x cubed. And I get negative 16x squared. And I get negative 32x. All right? Now I subtract these, but notice when I subtract, because they're all negative, they're going to be more like plus. So negative 8 plus 8, 0. Negative 11 plus 16, 5x squared. That's a 5x squared. And negative 9 plus 32 is going to be plus 23x, and then I drop down my 18, plus 18. So that 18 went right down there. Now, what times x squared is 5x squared? Well, it's 5. So I have plus 5 at the end here. 5x squared and plus 10x plus 20. And I subtract them once again, and I have 13x plus negative 2. So I end up with an answer on this one of 4x squared minus 8x plus 5. And remember that whole remainder thing we talked about? Here's how we deal with that. Remainder, 13x minus 2, and we take our remainder and we put it over top of the original. X squared plus 2x plus 4. And that's how we deal with that remainder. So here they're talking about the remainder theorem again, or for the first time, but we've just kind of discussed that. The remainder theorem says if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. I would not worry about what that means. Let's just skip right over that. That's not a big deal, and that's just to know how to work that remainder like I just did. Synthetic division. Here we're talking about synthetic division. It sets up like a problem we're going to see later in 5.2. The 0 of x plus 2 is negative 2, so I put that right here. X cubed, that's 1x cubed, so 1 goes in the first spot. 4x squared, the 4 goes here. Negative 5x, so the negative 5 goes here. 3 and 3. Now, if there was a 0 one, like let's say this was x to the 4th and we had 0x to the 3rd, we would have to fill that spot with a 0. But we have a 3, 2, 1, 0 progression, so we're good here. Now, here's how you're going to do each step of this. First step, drop that leading coefficient. That's 1. Then you're going to multiply negative 2 times 1 and put that answer right here, negative 2. You're adding, and you get 2. Multiply, negative 2 times 2 is negative 4. Put that right there. Adding, negative 9. Multiplying, 18. And we have 21 here. Now, what that results in, my answer now is going to be 1x squared, because when I divide an x cubed by an x to the first, you're going to get an x squared, plus 2x minus 9 plus a remainder of 21 divided by the original x plus 2. X plus 2. So it ends up being x squared plus 2x. How I think about it is I always do this. Right here on this one, I put a little r, so I know that's the remainder. No x, x, x squared. That's how I think about those. That helps me a little bit. Factor theorem. A polynomial f of x has a factor x minus k if and only if f minus if and only if f of k is 0. Meaning, if it is a factor of it, then when I put that k in there, k minus k would be 0. All right. Let's take a look at how that works. Factor polynomial. This is what we want to know. If I factor 2x cubed minus 11x squared plus 3x plus 36 completely, given that I'm telling you x minus 3 is a factor. Maybe you found x minus 3 as a factor by you, maybe you went on your graphing calculator and you found that when I graph this thing, let's take a look at that real quick. When I graph this thing on my graphing calculator, I went to my y equals and I typed in 2x to the third power minus 11x squared plus 3x plus 36, and I graphed that thing, and when I graphed it, I saw that I had a 0 at right here at 3, and it looks like I'm going to have a 0 at 4, but I really noticed there was a 0 at 3, and I went through and I calculated the zeros, and I found there was a 0 at 3. So I knew x minus 3 had to be a factor of it. So if x minus 3 was a factor of this thing, then I could put it into my newfound synthetic division. I'm going to put a 3 right here because that would make that 0. Drop my 2. I get a 2. 3 times 2 is 6. Add those up. 3 times negative 5 is negative 15. Get a negative 12. 3 times negative 12 is negative 36. And then what's my remainder? 0. A 0 remainder. Therefore, I found that this is x minus 3 and 2x squared minus 5x minus 12. And this thing's still factorable. Remember that 4 we saw on the calculator? Remember the, let's look at that again. Remember that 4 we saw on the calculator right there? There's a 4. So what if I took my equation there and I said, well, I'm just going to do this again. I'm going to put 4 into the 2, the negative 5, and the negative 12 and see what I get remaining. Drop the 2. Negative 5 plus 8, 3. 4 times 3 is 12. Look what happens. 0 for a remainder. Well, this is 2x plus 3. And if 4 is a 0, x minus 4. So I have factors of x minus 3, x minus 4, and 2x plus 3. That's one more way I could factor things. So for those of you who are struggling with factoring, this is another opportunity for learning how to factor. That might help you. Maybe you struggled in the last chapter and now you go, oh, I could have done that. Well, maybe that's a bonus for you. Maybe you still have to retake that test or something. So maybe it's be a good time for you. All right, let's take a look at what we have here. Example 4, find the zeros of this thing. Well, x equals negative 1. 1 0 is x equals negative 1. So I can put a negative 1 right here. All right. So when I drop my 1, there, I multiply and I get negative 1, and I add them and I get 3. Negative 1 times 3 is negative 3. I add them, I get a negative 18. Negative 1 times negative 18 is 18. I add them, I get a 0. All right, great. So if negative 1 was a 0, then x plus 1 must have been a factor, right? Because that would make that 0. So I know that I can put in my first slot here x plus 1. What do I have left over? X squared plus 3x minus 18. All right. So if I know, okay, numbers that multiply together to be 18, but add up to 3. One of them's negative, one of them's positive. Looking like 6 and 3 to me. So looking like x plus 6, x minus 3, and I have my x plus 1 here. That makes my zeros -1, -6, +3. Well, Mr. Emmy, why couldn't I use my calculator to find all those zeros? Well, you most certainly can. And if you take that calculator and you put into y equals, you put in here x to the third plus 4x squared minus 15x minus 18, what you'll find, delete that little piece right there, what you'll find when you graph it, it's that it goes through -1, 3, 4, 5, -6, and 3. -1, 3, and -6. Well, -1, 3, and -6, if it goes through those, then I have x minus -1, x minus -6, and x minus 3. Well, does that look familiar? Yeah, it's right there. Same thing. Minus minus makes a plus. Just one more way that you could have found that. You guys go ahead and take a look at that checkpoint 1, 2, 3, and 4. I'll show you the answers and we can answer any of your questions tomorrow. All right, welcome back. Hopefully you've tried all of these. You used long division, you used the different methods. Maybe you liked synthetic, so you said, you know what, I'm going to use synthetic on both. However you did it, on this first one you should have got x squared minus 2x minus 8, and you had a remainder of 23 over x minus 4, my original. And it was a -23, so maybe you had plus negative here, or maybe you just said minus here. Either way. On the next one, you had 2x squared minus 2x plus 3. And again, you had a negative, so it's a minus 15 over x plus 3. And on number 3, when you factor that completely, however you did it, maybe you used your calculator, maybe you used your super factor skills, 3x minus 1, probably on the 0 on your calculator on that one, you ended up with 1/3. You probably had to find that using your 0 function, and x plus 1 here. All right. And on that last one, -3 and -5. All right, we can talk about those tomorrow. Thanks a lot. Have a good day.